Version 3, question 1. We're still looking at planets in the TRAPPIST system on the basis that this is the one that's referred to on our datasheet. We've been given the equation that is on our datasheet. So things that we ought to know is when we plot it, that's going to be on our y-axis, that is our gradient, that is going to be on our x-axis, and we don't have a plus c, so it's going to go through the origin. So first off, complete the table of values, giving it to 3 significant figures. We've got 13.3, 84.9, 193 and 800. 585, 37.2, 84.8 and 352. This is not quite as nice a graph as the other one to plot, in that it does go up to 800 on your x-axis, but it does also give you a pretty much dead straight line. So if you plot that on your graph, make sure that you've got this on your x-axis and this one on your y-axis. When you draw your line, it's going to help if it goes through 0, 0, because you're about to work out the value of k. So by using your graph or otherwise find out the value of k, we know that our line goes through this point. So if it's going through this point, then we can use this as our y value, this as our x value, and when we work out k, we've got the change in y, so 352 minus 0 over 800 minus 0. And that is for part C. So that gives us an answer of k is 0.44. You may remember back on version 2 that we also got an answer of 0.44, but that's because if we're dealing with the TRAPPIST-1 system, we'll always have an answer of 0.44. Okay, so we've got value of k. We are now asked to express t squared in terms of r. This means that the only letters that we are allowed to use are t and r. So we have t squared equals our value of k, r cubed. Okay, part E. The average distance from the furthest planet is this, and we need to remember that r is in million kilometers, so that gives us a value for r. So we know that r is 3.345, and we can cube that, which will give us 37.4. So if we substitute that back into the previous equation, we've got t squared is 0.44 times 37.4. We are then going to need to square root that, and that is 16. So when we square root that, we've got a value of t of 4.06 days. For part F, we are told about the days and we need to find the distance. So we know that T is 12.36, and from there we know that T squared equals 153. We can substitute it back into our equation. So we have 153 equals 0.44 r cubed. So if we divide both sides by this, we get r cubed is 153 divided by 0.44. To find r, we're going to have to cube root that. That is 347. So we know that r is 7.03 million kilometres.